Hello everyone, this section is for Redox and ETC. After learning this section, you should be able to describe a redox reaction, noting the rule of the two half reactions and identifying the electron donor, electron acceptor, and conjugate redox pairs of the reaction. Redox reactions, they are of central importance in metabolism. The release of energy from an energy source normally involves oxidation-reduction reactions. Oxidation-reduction reactions, we also call it redox for short. These reactions are those in which electrons move from an electron donor to an electron acceptor. As electrons move from the donor to acceptor, the donor becomes less energy-rich, and the acceptor becomes more energy-rich. The more electrons a molecule has and is able to donate in a redox reaction, the more energy-rich the molecule is, such as glucose. Glucose can donate up to 24 electrons in redox reactions, so it is such an excellent source of energy. Each redox reaction consists of two half reactions. One is oxidation reaction and the other is reduction reaction. This formula shows acceptor get electrons. It is the reduction reaction, and the donor lose electrons. It is the oxidation donor. The acceptor and the donor of a half reaction are referred to as a conjugate redox pair. The equilibrium constant for redox half reaction is called the standard reduction potential and is a measure of the tendency of the donor of a half reaction to lose electrons. Look at this picture. Electron acceptor NAD and NADH. The NAD-NADH conjugate redox pair have a very negative reduction potential, and NADH can therefore give electrons to many acceptors, including oxygen. And see this picture. It shows the electron movement and reduction potentials. You can see on the top of the picture is glucose and carbon dioxide. So the glucose has the most negative reduction potential. Then let's see the electron transport chains. They are a serial set of sequential redox reactions. From the glucose, it can donate electron to NAD, and NAD is changed to NADH, and NADH can transfer the electrons to oxygen, and oxygen becomes water. This is a process of catabolism. During this process, EMP pathway, ED pathway, and TCA pathway can produce electrons, and ETC is for transferring the electrons. This picture shows the location of the ETC. Picture A shows the mitochondrial ETC, and picture B shows the bacterial ETC. The first electron carrier in an ETC has the most negative reduction potential. Each successive carrier is slightly less negative. Thus, electrons are transferred spontaneously from one carrier to the next. The carriers direct the electrons to the terminal electron acceptor, in the case oxygen. This picture shows the creation of a proton gradient by the mitochondrial ETC and its use in synthesis of ATP. You can see the transferation of electrons, and oxygen accepts the electrons. In this process, ATP was produced. That's all for this section. Here is a word list for you.